All right, now here we go again with factoring by group, or factoring a leading coefficient not 1 in a trinomial, and not doing it with grouping, doing it the traditional method. So with 15 here, I'm going to first of all find the factors of 15, so 1 and 15, and 3 and 5. Those are my only factors. Now 1 and 4 for 4 down here, and then 2 and 2 for here. So with this time around, I'm going to have to use either the 1 and the 15, so I have an x here and a 15x here, and like I said before, I'll prepare for that. And then I could either put a 1 and a 4 in, or a 4 and a 1. So I could do 1 and 4, and then I check that, right? I need a difference of 4. So outside's 4, inside's 15. No, that's not going to cut it. So I also have the choice of putting in here the 4 out here and the 1 here. So outside's 1, inside's 60. No, the difference is not going to be what I need. So this one's not going to work. So the other choice is I could have the x and the 15x, and I could have those with 2's. Well, luckily the 2's are exactly the same, so there's only one choice, 2 here and 2 here, right? So outside's 2, inside's 30. No, that one's not going to work. So I've exhausted all of those. So now I'm down to saying, okay, well, I could have a 3x and I could have a 5x. And now I can either put that with the 1 and the 4 and or the 2 and the 2. If I put it with the 1 and the 4, I have two choices. I could put the 1 in here and the 4 out here. So I have a 12 on the outside and a 5 in the inside. 12 minus 5 is 7. Nope, that's not going to work. So I could put the 4 over here, and I could put the 1 in here. So if I do it that way, I have a 3 on the outside and a 20 on the inside, and the difference is still not going to be what I need it to be. So that one's not going to work either. So now I have the 3x and I have the 5x, and now my only choice is a 2 and a 2, and there's only one choice there, right? Because if I switch them around, it's no different. So outside is 6, inside is 10. The difference between 6 and 10 is indeed 4. Now I have to make that difference correct, so I need a difference of a negative 10 and a positive 4. And there we go. Now remember our factoring by grouping strategy? Our factoring by grouping strategy would have said, okay, 15 times 4, and then I get the factors of that. So I have 60, and 1 times 60, and 2 times 30, and 3 times 20, and then 4 times 15, and 5 times 12, and 6 times 10, and 7 doesn't go into it, 8, no, 9, no, and 10, we're back at our middle. And these give the difference, and look what we found. We found a difference of 6 and a difference of 10, and those are what would give us our factoring. So the factoring by grouping strategy can be used as a jumping off place. All right, now this one, look at that. That x squared one, I don't want it to be negative. So the first thing I'm going to do is I'm going to take that negative out, which will leave me with a positive 2a squared and a positive 5a and a positive 2. And then finally, I can think about this. 2 times 2 is 4, and 4 plus 1 is 5. So I need to make the products of 4 and 1. So I can do that quite easily by saying, well, 2a and a, that's how I'm going to make this 2, right? And then this 2 down here I can make with 2 and 2. I can't put a 2 in here because that would be a GCF. So I put a 2 here and a 1 here. And look what I have. 2 times 2 is 4, and 1 times 1 is 5. And this is a plus here and a plus there. And that finishes my problem. So we have 2a squared. 4 plus 1 is 5a, and 1 times 1 is 2, and it's the opposite of that. And that'll finish my factoring in that particular problem. All right, now this next ones we're going to add our factoring by grouping. So you might want to take a look at some of these and see if you can do those by yourself, and then come back and try the year turns after that. So we'll do one video for the factoring by grouping, and then another for the year turn.